Okay, so today's class we'll see the matrix methods. Matrix methods, simple understanding. We already completed matrix methods chapters, but so many people complaining that we can't feel the differentiation between flexibility matrix methods, stiffness matrix methods. We discussed every problem in 2 by 2 matrix or 3 by 3 matrix, but we can't catch up. So that's why I recorded this video. I will explain same methods in just one variable. Just one variable. Okay. So then you can easily understand the difference between those two. Just one variable, not two. If two is variable, you will get 2 by 2 matrices. Two indeterminacy. Two static indeterminacy get 2 by 2 in flexibility matrix. Two kinematic indeterminacy, you will get 2 by 2 stiffness matrix. But now it's only one indeterminacy. Same problem I will solve in stiffness matrix method and flexibility matrix methods. Then you can easily catch up those uh, ideologies, those methods. Okay, so once again, stiffness matrix, flexibility matrix methods. Just one variable, one indeterminacy. Okay, so take a simple problem. Propped cantilever. Propped cantilever. So this is L by 2, this is L by 2. So what is the static indeterminacy? Static indeterminacy. What is the static indeterminacy? 3 minus 2, 1. There is no horizontal force. There is no horizontal. We can't consider the horizontal forces are equal to 0. That's why inversely equations. Just remove it. So 3 minus 2, 1. So what is the kinematic indeterminacy? Again 1. That is what? This is A, this is B. We consider this. You can get it. Theta B is the kinematic indeterminacy. This is a dk. So what is the static indeterminacy value? You can choose anywhere. This is MA, VA, this is VB. So MA, VA, VB. You can choose anyone. Anyone is the indeterminacy. Because only one is the indeterminacy. You got that one value. Remaining two you can get by equilibrium equations. Okay. You can choose anyone is the indeterminacy. I will explain later. I will solve the problem. Okay. So 1 dk is 1, ds is also 1. So first I will solve this problem in stiffness matrix methods. What is the stiffness matrix methods equation? Stiffness matrix matrix equation is force vector is equal to the stiffness matrix displacement matrix plus fixed force vector. Fixed force vector. Are understood? So the same way, what is the flexibility matrix equation? So displacements, final displacements is equal to the flexibility matrix multiply with force matrix plus free displacements. These are the two. These are the two equations. Are understood? You know it. Now, these are the two equations. Now I will solve by stiffness matrix methods. See the equation and you will get the meaning. Not a mathematical way, just meaning. So I will solve this problem in stiffness matrix methods first. Okay? Stiffness matrix methods first. So what is the start equation? This is So what is the kinematic intimacy? Theta b is the degree of freedom or kinematic intimacy. So okay, theta b is the, so what is the procedure? First you will fix the, fix, though this is theta b, fix the degree of freedom. First fix it. So now you can feel, you can fix it, you can fix, arrest the degrees of freedom. First arrest the degrees of freedom. What you will get? The fixed end moments. What is the fixed end moments? This is pl by 8, this is pl by 8. So you can get any direction. This is a, if you take an anti-clockwise is positive negative, clockwise is positive. This is, you just arrest that, arrest the degrees of freedom. Later arrest the degrees of freedom, you will get fixed end moment. This is the fixed end moment. Are understood? This is the degree of freedom. Okay, so next, write down the stiffness matrix. Write down the stiffness matrix. In this only one is the indeterminacy, so you will get only one by one stiffness matrix. How to write it? How to write it? You first give a unit displacement. First give a unit displacement, unit displacement in the direction of the kinematic intimacy, in the direction of the degrees of freedom. Write down the force. Write down the force. See, I will write it. You will give unit direction. See, unit displacement theta b is 1 in the direction of the clockwise. Give it, give it. You will get this unit. How much force arises? 4a by l. You know it, because if you apply m moment, see, I will write here. If you apply m moment, you will get theta is what? ml by 4ei. You know it. So if theta is 1, what is m? M is 4ei by l. You know it. Okay, so that's it. So k is 4ei by l. 4ei by l. So write down the final equation. See, force, final force equal to stiffness matrix 4ei by l, rotation is theta b plus fixed force moment. That's what it, what is the value? That value is pl by 8. pl by 8. And final moment is what? Final moment at the location of the mb. Mb is what is the final moment? It is a hinge, na? It's a hinge. Final moment is 0. This is 0. So this is 0. Okay, this is 0. So exactly what is the now theta b is value? Theta b value, see it, p l square by 32ei negative. So just observe it. What is the meaning? Not a value, not a value. Just observe it. So it is mb at that location. Final moment is 0. If you arrest the degrees of freedom, you will get pl by 8 moment. Arrest the degrees of freedom, you will get the pl by 8 moment. But if in the same direction, see, the degrees of direction, if you allow one unit rotation, this much amount of force, this much amount of force is generated. How much rotation is allowed? How much rotation is allowed? That the moment is exactly equal to the pl by 8. Then finally what will happen? The degrees of freedom is released, the moment it gets 0. So what will happen? That will finally C is the pl square by 32l. If you consider this, so l by 2, l by 2. So now you can understand what is the curvature diagram. What is the curvature diagram? You will get like this. That's it. This is the theta b. What is theta b? pl square by 32a negative, anti-clockwise direction. You see it. So what? Just now observe this meaning. So if it is arrest the degrees of freedom, you will get this amount of moment. But finally, we release that degrees of freedom, it's a delta b, theta b. So in the direction, if you release 1 unit, you release 1 unit, you will get this amount of force. How much the frame is rotated or release that theta b, you will nullify that moment of pl by 8. This amount of rotation will occur. That is the meaning of this equation. Are understood? Once again, got the point? That's it. Now, once you got the kinematic indeterminacy or degrees of freedom or kinematic indeterminacy, remaining you can get by slope deflection equations. What is ma? What is ma? Fixed end moment pl by 8 plus 4ei by l into theta a plus 2el into theta p. Theta a is 0. Theta a is 0. So what you will get? Minus pl by 8 2ei by l. Theta b, what's pl square by 32a. 16 is negative, so minus 3pl by 16. Okay, that's it. Once ma you got it, remaining you can by simply equilibrium equations. It is 3pl by 16 anti-clockwise direction. So what is vb? What is vb? You can write the equation vb multiply with l, vb multiply with l minus pl by 2 plus 3pl by 16. vb multiply with l plus 3pl by 16 minus pl by 2 equal to 0. vb is 5 by 16 by p, so automatically this is 11 by 16. So that's it. You can draw bending moment diagram, shear force diagram. We analyze it. So just feel that understanding of what is the equation, understanding the equation. Understood? This part, per 1 unit rotation you will get this much amount of force. How much rotation is occurs to nullify this amount of bending moment? Because if you arrest it, if you can't control, if you prevent the rotation at the joint, you will get this much amount of moment. But finally we allowed it because it has a hinge support, so we allowed it. How much of degrees of freedom or how much of rotation will occur, we want to find out. So per unit rotation this much amount of force, how much it rotated to nullify the pl by 8 moment. So that's the equation. Got the point? That's it. So now the same problem I will solve it in flexibility matrix. Okay, flexibility matrix methods. So vb, va, ma. So what are the reactions? ma, va, vb. Static indeterminacy is 1, so you can choose any one. You can choose any one of these reactions as a static indeterminacy. Now first I will choose vb is as the static indeterminacy. vb as the static indeterminacy. So indeterminate reaction, you can get any one of these. Remaining values you can get by equilibrium equations. I will first I will solve this problem by two different variables. I considered ma one time, vb one time. Okay, I will show you. Okay, first I will choose vb. So what we will do? So once again see the flexibility matrix equation. Final displacements is equal to the flexibility matrix multiply with force plus free displacement. Are understood? So what is the free displacement? Now you can consider it. So vb is the static indeterminate reaction. So first release it. So how can you release it? Release that support. If there is no support, you can't get vb. If it is a support, then only you will get a reaction. Are understood? First, remove the support. First, remove the support, and what you will get? What you will get? A deflection diagram. Something deflection, something delta B. What is delta B? What is delta B? You can easily calculate it by this displacement and this displacement, because this is a curve, this is a straight line, because there is no movement here. So you can easily you can easily solve. So what is this value? This value is PL by 2 PL cube by 3a. What is the slope here? PL by 2 square by 2a. Slope into this distance is L by 2. L by 2. The got point? So exactly that is what is 5 by 48 PL cube by EA. Otherwise you can solve this by conjugate beam method. You can solve by conjugate beam method like this. Fixed end is free end is fixed. You can impose bending moment diagrams. What is the bending moment here? So up to this there is no bending moment. It is the bending moment of PL by 2 divided by EA. So you want here is the delta, so displacement. You will find out the bending moment here. Okay, bending moment here. What is the bending moment that location? That's exactly equal to the displacement. In the conjugate beam, bending moment is equal to the moment equal to the displacement. Shear force is equal to the rotation. You already know it. Okay, so see, this is L by 2, this is L by 2. So this total load acts here. So what is that exactly? What is that load? What is that load? PL by 2EI multiply with L by 2 multiply with off. That is the load. Distance is L by 2 plus this 2/3 of L by 2. This is 2/3 of L by 2. That is L by 2. So you will get same thing. 5 by 48 PL cube by 3A. You can get the displacements and rotations by any means, any method. Double integration method, conjugate beam method, area moment analysis. So many methods are available. So many methods are available for calculating the displacements and rotations. You know it. So now what we will do? Now what we will do is see, develop the flexibility matrix. How can you develop this flexibility matrix? Just a frame. No need of flexible forces. In the direction of the redundant direction, in the direction of the redundant, you will apply unit force. You will apply unit force. How much deflect it? How much deflect it? This help. In the direction of the redundant, you will apply a unit force. Unit force, how much the deflection will occur. That is the flexibility. Per unit force, how much displacement is the flexibility. Per unit displacement, how much force is generated is the stiffness. You already know it. So what is this value? What is this value? Flexibility F11. What is PL cube by 3. That's the flexibility. So now write down the equation. So final displacements are equal to flexibility multiply with force multiply with free displacement. So I will write down flexibility is PL cube by 3A. Sorry, there is no is a 1. Force is VP plus displacement is 5 by 48 PL cube by 3A. So what is the final displacement? What is the final displacement? Is 0. How it is? See, you already know. What is the final displacement here? In the direction of VB, there is no displacement because it is support. We never allow a displacement. Are you understood? There is no displacement here in the direction of VB. So what is the meaning here? Just observe the meaning. So if there is no support, see, if there is no support here, you will get this much amount of displacement. If there is no support, you will get this much amount of displacement. In the direction of VB, if you, per unit force, if VB is just 1, you will get this much amount of displacement. How much VB is generated? Such that the final displacement is exactly equal to 0, or the final displacement is exactly this much amount. Are understood? If there is no VB, if there is no support, you will get this much amount of displacement. In the direction of VB, for unit force, you will get this much amount of displacement. How much amount of VB is generated for to make the displacement is 0, or to counteract this displacement, to make it as 0. I understood? Get the clarity? So now if it is VB is generated, means that is the support. Final displacement is 0. If the displacement is allowed, there is no reaction. If the displacements are prevented or curtailed, you will get reactions. Or get it? See, that's it. This is the equation. Now, final displacement is 0 per unit force. For unit force, this much amount of displacement is occur. How much VB is generated to exactly balance this much of displacement? To get final displacement is 0. Got the point? Same as it is in the flexibility matrix. We discussed previously. Exactly opposite manner. So what is the VB? VB will get, see, 3 3 16, 5 by 16, 5 by 16 P negative. So that means this is, we choose, this is the flexibility opposite direction, not this direction, not downwards direction, it's upward direction. I got the point? Upward point. We develop the flexibility matrix. We apply unit force to the downward direction. Okay, 1 minute. So that's it. Once you got the VB value, remaining you will get by, simply you will get by, so in this direction you will get by 16. So what is the remaining value? It's 11 by 16. So what is the moment? You will get 3 PL by 16. That's it. That's it. So same problems to be the same problem. I will choose different static indeterminacy. Okay. It's VB, VA, MA. Previously we choose VB as the static indeterminacy. Now I will choose MA as the static indeterminacy. You can choose anything. Okay, so what we will do, just remembering what we did previously, remove the redundant. If you remove the MA, if you remove the fixed end moment, what will happen? If you will remove the fixity, it will convert into a hinge. That's it, na? That's it. So if you remove it, exactly what will happen? It's a hinge. If you remove it, it feels like it acts as a hinge. Just remove the fixity. Feel as a hinge. Okay, so write down the displacement write down the displacement when we remove the redundant. So here we remove the fixity. So what we will get? We will get a rotation at that side. Rotation. So always understand if it will, you will get a rotation. For for removing the indeterminacy. I understand if you just remove fixity, you will get rotation. Are understood? Yes. So for moment, you will get rotation. For force, you will get displacement. If you remove the force, you will get displacement. If you remove the moment, you will get rotation. Understand? If you prevent the displacement, you will get reaction force. If you prevent the rotation, you will get fixed and moment. If you prevent the rotation, you will get moment. If you prevent the displacement, you will get reactional force. Okay. So what is this value? Theta A, this theta B, this P, L by 2, L by 2. You already know it. You already know when point load act at center, what is the rotation? What is the slope at the sides value? That's theta A or theta B. Everything is equal to the PL square by 16A in the direction. You already know that. Otherwise, if you don't remember the equation, just use the cantilever. See, conjugate beam method. So hinge is roller, roller is hinge. So what is the bending moment? You already know what is the bending moment diagram. What is the bending moment diagram? PL by 4. So you want rotation at this location, just to find out the shear. That's it. So what is the shear? VA or just VB, you just feel it. So what is VA? Exactly total load is equally distributed from VA to from in between VA and VB. So what is the total load? Exactly directly I write theta A, or here is VA, here is VA. What is the total load? Of PL by 4 into length. That is the total load is equal to half. That's it. That's value is PL square by 16A. PL square by 16A. Are understood? Exactly in the clockwise direction rotation you will get. So now you will get flexibility equation on the removed flexibility matrix. If you apply a unit rotation, apply a unit moment, apply a unit moment, write down the allowable displacement. Displacement means here is the slope. Apply a unit moment in the direction of the redundant force. Apply a unit moment in the direction of the redundant force. Write down the displacement. Here is rotation. How can I? What is the value? Here, that is the theta A, is theta B. No need of theta B, just theta A. What is theta A? So you already know what is the theta B is L by 3. So if you don't know, just is a hinge simply supported beam. If you apply M moment, here is ML by 3A, here is ML by 6A. You already know it. You already know it. This is M is here 1. M is here is 1. If you don't want to remember the equations, just write down the conjugate beam method. Conjugate beam method. Roller hinge roller. Write down the bending moment diagram. What is the bending moment diagram? Just is the moment of 1. This is the bending moment diagram. This is the bending moment. 1 divided by A. M by A curvature diagram. So if you impose the curvature diagram onto the conjugate beam, that's a bending moment diagram. Bending moment diagram is that's it. This is 1, this is 0. That's it. So if you want rotation, you just find out the reaction, that's a theta A. What is that value? So total load is what? 1 by A, 1 by A L in multiply with half, that is total load. How is it distributed to in between VA and VB? Distributed in between VA and VB. So VA get larger portion, VB get smaller portion. How much? How they will take each other? By exactly 2/3 portion will come to the VA, 1/3 portion will come to the VB. You know its centroidal distance is 2/3 and 1/3. You know is 2/3 L, it's 1/3 L. So 2/3 portion will come to VA, 1/3 portion will come to VB. So what is that? 2/3 of L. So what is that value? Cancel, cancel. L by 3. Understood? So L by L by 3. Okay, that's it. That's it. Okay. So now comes to the flexibility matrix. What is the flexibility matrix? What is the flexibility matrix? What is the flexibility matrix? Flexibility matrix equation. Final displacement equal to flexibility multiply with force plus free displacement. Free displacement. Now just write down. Write down. What is the flexibility? L by 3A per. What is the unknown value? MA. MA. What is the free displacement? Free rotation you will get. What is you will get? PL square by 16A. PL square by 16A. So what is the final displacement? Displacement means rotation is 0. So what is the meaning? Just understand the meaning. If there is no MA, this much amount of rotation is will occur. For this much amount of rotation will occur if there is no MA. If it is just a hinge support, there is no moment. Are understood? If it is a hinge support, there is no moment. But we prevent the rotation at A. We prevent the rotation at A, theta A. So that's why MA will generate it. If there is no MA, this much amount of rotation will occur. In the direction of MA, per unit moment, this much amount of rotation will occur. How much moment will exactly balance this much amount of rotation? Are understood? Per unit MA, this much amount of deflection will occur. How much amount of MA will generate to exactly balance this much amount of displacement? Displacement means here is rotation. Are understood? Then that's okay. See it. 2/3. 2/3. Okay. So this is the total load. So 2/3 parts here will come. 1/3 part will goes to VB. So if you see 1/3 L by A 1 by 2 is 1 by 1/3. You will get L by 6. Yeah, we already said it. Just a single small derivation. Okay, small derivation. So what is the meaning? Per unit moment, this much amount of rotation will occur. How much moment is generated such that final deflection exactly equal to this amount, final rotation will be equal to this amount, and the deflection is we prevent that deflection. If there is no MA, this much amount of displacement rotation will occur. If MA is generated 1 per unit moment, this much amount of rotation will occur. How much moment is generated such that it balances exactly this much amount of rotation? Are understood? That's why the final displacement is 0. Final rotation is 0. You know it, no? You know it. Final displacement is final rotation at this location theta A is 0, no? That's it. So solve it. You will get MA is equal to the minus 3PL by 16. So what is the meaning of minus? So see it. We generated. We taken that direction is clockwise and the rotation is clockwise. Here also we taken clockwise rotation. Clockwise rotation. So you will get a minus means anti-clockwise movement. That means what does that mean? That means you will get anti-clockwise moment of 3PL by 16. Once you got 3PL by 16, what remaining you will get by equilibrium equations. What is the VB? What is VB? VB multiplied with L plus 3PL by 16 minus PL by 2 equal to 0. VB is 5P by 16. 5 by 16P. So remaining is, that's it. Understood? That's it. Now you can get exactly the meaning of stiffness matrix and flexibility matrix. Once again I will write final force equal to the stiffness matrix multiplied with the displacement plus fixed end force. We solve the problem. Okay, final force is almost equal to 0. Otherwise, if you allowed something, you will write down those things. Here, flexibility. Final displacement is equal to flexibility matrix multiply with force plus free displacement. Now you got the point of stiffness matrix, flexibility matrix, flexibility matrix methods. Understood? That's the idea. Now we understand the first one by one variable, only one variable, one indeterminacy. For two variables, we already solved the problem, just see it. We already solved the problems when two indeterminacy, three indeterminacy. You can develop the flexibility matrix or you can develop the stiffness matrix and you can solve the problem by the same means. Okay. Now, if you see it, the same problem you can solve in moment distribution method within 1 minute. Within a minute. Are understood? So what is the fixed end moments here? If you fix it, what is the fixed end moments? PL by 8, PL by 8. So it is minus PL by 8 plus PL by 8. Moment distribution method. So final moment here is 0. So you allow just, if you just add minus PL by 8, final moment here is 0. So automatically what you will get? Half of the moment transfer to the far end. So what is the half of moment? So now it's 0. What is that? 3PL by 16. This is moment distribution method. 1 minute. You can check it. Moment distribution method. Okay. Same problem you can solve in slope deflection method. What is MBA? Is A. It's B. MBA is fixed end moment plus fixed end moment 4EA by L into theta B 2EAL into theta A. That is the final moment MBA. So final, what is the final moment? MBA is 0. There is no moment at the location. What is theta A? 0. You can place it. You can solve it. You can solve it. Theta B you will get PL square by 32EA negative. Once you will get theta B, you can place it on MA, you will get MA value. This is slope deflection equation. Slope deflection method. The same problem you can solve in strain energy method, column analysis method, anything. So I hope you understand matrix methods in a simple way. Now we can easily understand two indeterminacies in flexibility matrix or stiffness matrix, or three indeterminacy. So now we can able to solve the problems of beams, frames, trusses, anything. But just making, just my intention is just understanding the basic idea of flexibility matrix and stiffness matrix in a simple tone. Okay, thank you.